Hi and welcome to challenge number 12, find maximum. In this challenge, our task is to return the largest number in an array. For example, if we have an input array like this, the largest number within there is going to be 23. Let's go ahead and let's try to implement that first in JavaScript. In here, I'm going to define a function that is going to find the maximum of any input array. And that the input, I'm going to call it an array. So the function parameter is ARR array, and that's what the function is going to accept as an argument. So there are going to be, of course, a few edge cases. What if the user passes an array that's empty? So I'm going to say array.length. If this is equal to 0, this means the user has passed in an empty array. And in that scenario, I'm just going to return 0. And when we say we want to return the maximum of several numbers, the first thing that we need to do is we need to filter out all the numbers from our input array, because chances are we could get a mixed array where we have strings and numbers. We could have an array that has only strings. So in that scenario, we don't have any maximum. So we need to handle all these edge cases. So I'm going to grab our input array, and on there we can basically invoke or call this filter method. And the filter method is going to implement one logic that's going to be filtering something out of the array based on some certain condition. If the condition is true, it's going to keep that. If the condition is false, it's just going to leave it behind. And we just want to keep the items that are numbers, because then we are just going to compare those numbers together to find what is the maximum of them, what is the biggest or largest number. So this filter method, it is going to require, much like our for loop, it's going to require an I, which is a loop agent, something that jumps into that input array and it selects one item in every iteration. And it implements the same logic on every individual item. So that loop agent is going to be item. And what is it that I want to do? And I need to come up with a way to be able to understand if the item that this loop agent has gotten, if that's a number, or if that's something that can be converted into a number. So we have this is in a n method inside of JavaScript. What this does is it is going to accept something and it is going to return true or false. If it returns true, this means that's not a number. That could be anything, but it's not a number, all right? But if it returns false, that means it's a number. So when does it return false? When I flip its value. And I'm going to pass an item here. So if it returns true, it's a string, which I don't care. If it returns false, that's going to be a number. That's something that I care about. So is not a number is going to return true for a string, because string is not a number. But it is going to return false because number is not a number. It's a double negative, which produces a positive for us. And I could also check for another condition, and that condition is when our item is actually also not an empty string. Now, what is this going to give me? Well, this is just going to filter out all of the numbers from the input array. Well, it is also going to filter out everything that can be converted to a number. And what is that? Any number that is surrounded by quotes that can be converted into a number as well. So I have already these test cases. I've already created these test cases, so I don't have to wait. I don't waste your time, and we're going to go over this. In our very first test case, we have this normal array that we pass in. You can see it's our input array. We know that the maximum is going to be 23. We have this empty array for which we need to return 0, which we already did. And if we have an array that is all strings, we need to show a message like this. We are yet to create this, so just hold on. For now, we're actually talking about this part. So we have 10, and then we have a string, and then we have 23, then we have another string convertible to a number, and then we have 5. So if the user passes something like this, what this numbers is going to contain is going to be 10 23, 150, and 5. And we could actually log that as well. So I'm going to say console log numbers, and then let's first cd into 12. I've already opened up 12, so I am there. I don't need to cd that. Okay, node, find maximum, and there we go. So we have all of these, and we have these messages which are undefined. So let me, you know what? Let me just comment out these parts and comment out these parts as well. There we go. Much better, right? So I'm going to bring this up, clear this, and run this again. And there we go. So what do we have? We have this mixed 10, hello, 23, 150, and 5. So if this is the user input, you can see this is the string that we have within our console log. What is the numbers array? This is our numbers array. So I could just call this numbers as well, put it in quotes so you can really see what I'm talking about. So here we go. We have, this is our numbers array. And take a look at this. We have 10, we have 23, we have something that can be converted into a number, and then we have this 5. So technically, we just have 4 numbers. Now, what do we need to do next? Well, we need to convert this thing into a number as well. And then we can find the maximum. So let's convert it. Now, I could do this on the same line. So I could just call in a map method. Why? Because filter actually creates a new array. So technically, I can call a map method on that new array, which is this numbers. You can see numbers in the log. That is a new array. So I'm going to say map, give me everything that is a number. So this is like the mother number type that is going to be used in JavaScript. And this is going to any object that represents a number of any kind. So it's just going to produce for us the numbers. Now, as soon as I run this again, I need to save that, run it again. There we go. So you can see all of these are like yellow color. That means all of them are numbers. So now that I have all numbers, what do I need to do? Well, I need to return the maximum, right? So there is just a lot of different ways you could go about this, but I wanted to make use of this math module of JavaScript as well. So on the math, we have this max. And this is going to accept, as you can see in the function definition, it is going to accept an array that has numbers. But what is it going to produce for us? Whoops. So if I hover on it, where did it go? Here we go. There we go. So we got the math.max. What it accepts is going to have a type of an array of numbers, but what it produces is a single number. And it says returns the larger of a set of supplied numeric expressions. And if you take a look at this parameter part, this is very interesting because what we are doing is we're spreading the array, and then it is going to take a look at every individual item, and it's going to see, okay, which one of them is the bigger one, or it is the largest of them. All right, but you need to spread the array. That's something that you need to keep in mind. So I'm going to put in 3 dots. And what do we mean by spreading? By spreading, we actually mean we take away. We basically get rid of the square bracket at the start of the array, and at the end of the array, we spread all the items inside of this numbers. So it is easier for us to calculate that. And this is going to return the largest. But what if we just have strings there? Well, we didn't handle that one, right? So what I need to do is, well, before doing that, let's first see what this numbers is going to return for us. So I'm going to run this again. Take a look at this. So it was able to get us this, and the maximum of those is that number, which was a string. And we converted that back to a number, and that 150 is the larger of them. But what if we pass in all strings? What happens in that scenario? So in this scenario, we know what happens in the empty array. We know what happens in the upper one. But what if we just pass in all strings? So let me clear this out. Now, if we pass in all strings, we get minus infinity. Well, we don't have to get that. What we need to show, we should show is you need to pass numbers. That should be our message. So I'm going to get rid of our console log. We no longer need that. So I'm going to say if I don't have anything inside of my numbers, meaning that I didn't find any number using this method, and I didn't find anything that I could convert into a number, then that means I don't have anything inside of my numbers array. And in that scenario, that's only the case if the user has passed only strings. But you might ask, okay, what if the array is empty? Well, we already handled that. If the array is empty, the function is going to stop at line number 2. It's not going to even go to line number 4. It's just going to stop executing at line number 2, and it's going to return 0 for us, and that's it. It's going to exit the function. This return is going to exit the function, and that's it. We are not going to get to line number 4. We get to line number 4 if we have something inside of the array. That's the only possibility. And if that thing or things or those things are not numbers, then this numbers array is going to be empty because we filter out only the numbers, not anything else. And if this numbers array is empty, the only possibility is that the user has only passed in strings. So I'm just going to say you need to pass in numbers. You need to pass numbers. And that should be it for us. And now I could basically comment everything in until here, save that. We're going to take a look at different test cases. So find maximum. What do we have? For the first array, we have 23. For an empty array, we have 0. If we have apple and banana, which are strings and cannot be converted to numbers, we just say you need to pass numbers. For this one, we already talked about this 12. I have also handled floats and integers. It doesn't really make sense in the world of JavaScript, but still, I want it to be there for when we get to like lower level languages. So we have this 12. And then if we have floating point numbers and strings, we have this 4.7, which is the largest of them. And now that we're done with the JavaScript one, let's jump into the TypeScript solution. I could zoom this out because there's just too much information. So the first thing that I'm going to do is we're going to grab all of our console logs and I'm going to put it at the bottom in here. So how are we going to solve this for TypeScript? Now for TypeScript, this is way too zoomed out. I need to zoom this back in. For TypeScript, we are going to use something, we're going to employ a tactic, which is called a single pass algorithm. So that's how I go. If this is your first video watching this series, when we go to the TypeScript solution, which is the second language, we try to peel away the abstraction. So how this would work if we were to just go as manual as possible. So there we go. We have a function, and this function is going to calculate this logic for us. The name of this function is find max. Now, our test cases is going to be the same thing for all languages, because all languages, regardless of their implementation, the solution has to be the same thing. And let's come back to this function. So this function is going to accept an array. But since we are inside the world of TypeScript, we can type annotate this. We can say we only want to accept numbers and strings, but this is going to be an array. However, what this produces, what this function is going to return is going to be either a number or a string. And the string is going to be our message. And let's get started with handling our very first edge case. That's going to look similar to how we did it in JavaScript. So if the length of the array is 0, that means if an empty array has been passed, we're just going to terminate the function here and we're going to return 0. Now, what if user did not pass an empty array? What if the array has something? Now, we need to create a couple of state variables to keep track of our changes. One of them is going to be max. This max is going to have a type of a number, and I'm going to initialize it to 0. Why? Because inside of our, I need to keep this JavaScript open. Now, inside of our JavaScript solution, what we did was we used the math.max method. This is a method, right? It basically it gives us an abstraction layer so we know what it is that we're doing, and it is easier to work with. But I'm not going to use this max method, which is going to take a look at, okay, what is the biggest of these numbers or what is the largest of them. I want to do that manually. So if I want to do it manually, I need to have a variable that is going to hold the maximum number for me so I can reference it. And why do I need to reference it? I'm going to come back to this. So we have this let max, which is of type number, equal to 0. Why? Because that's going to be our initial starting point. It's going to be 0. So we are checking everything against 0. Okay, so that's 0. Now, we need to also have another state variable that is going to let us know if we have any numbers inside of our array. If user passes apple and banana, well, we cannot put apple and banana inside of max. And we cannot even compare the value, which is apple, with the value of max, which is 0. We can't compare that. So we need to have some sort of a state variable that is going to help us decide if we have a number or if we have anything other than number, which is just going to be a string. So I am going to create a state variable, and that is going to be called has valid numbers. Initially, we're going to set it to false. Why? Because we have not actually iterated over our array. We don't know what that is, but we are going to assume it is false. Why? Because if it is set to true, in no scenario will we be able to actually compare the value of the first array of the first item within our array with our max. So we need to give that wiggle room. So we jump into the array, we get the very first item of that array. If I set it to true at the start, we're not going to jump into that array. And I'm going to explain this as we go ahead and as we actually create this, we come up with the logic. So here is our single pass algorithm. And the idea behind this is, now, before saying this, before explaining this, you might have noticed something that even though these are like challenges that you need to do and it makes your programming skills better, but we're not actually talking about like the deeper concepts in data structures and algorithms. We're not talking about space complexity or time complexity. Here and there, I throw in some words like we talked about the bubble sort algorithm a while back. Now we're talking about the single pass. That's intentional. I don't want to talk about these more difficult concepts that require a little bit of mathematics as well. For now, I just want to have fun with these challenges. And then as we move forward in the series, and as this is going to get higher and higher and more advanced, I'm going to introduce those topics as well. For now, I just want you to practice your programming skills, and that's it. Just practice how to solve a solution, how to solve a challenge, how to get to a solution, to the solution, but the implementation you come up with that could be different, and that's okay. And I even encourage that. So a single pass algorithm basically means that we do everything in one go, and that's it. That's a single pass algorithm. So it's like we have one giant block of code, and within that giant block of code, we implement all of the logic in order to solve this challenge. We don't separate it into different parts. And in JavaScript, we did. So we had this part, which handled two things. It handled everything from any individual array that is a number and that can be converted into a number. So that was thing number one. And thing number two was that it converted all of those into a number. So this did two things. And then this also did two things. So we spread the array and then we found the maximum of that. But you can see these are in two different places. So that's two different logics. But for our max for the single pass algorithm, we're going to do all of that within one block of code, within one curly brace, one set of curly braces. And that's going to be a loop for us because we have an array and we need to compare one item of the array in each iteration, in each time we go into that array. So the logic that we use is actually going to be a for loop, because this is the most manual it's going to get. So we have this loop agent, which is going to be I. This is going to be every item of the array, but in one iteration. So in the first iteration, if we talk about the first array, it's I is going to be 10. In the second iteration, I is going to be 4, and then I it's going to be 2, and then 23, and then 15. Why? Why do we do this? Because is it easier for me to repeat this logic that's going to select these 5 items 5 different times, and then for the next array, I don't have to repeat it, and then for the next array, I just have to repeat it 2 times, and then for the next array again 5 times, and then again 5 times, and then this is 5 for some reason as well. So you might have 10 arrays, an array that has 10 items, then you need to repeat it 10 times. So it has a variable number of items. And you don't want to have something that's hard-coded. Your code has to be as flexible, I'm throwing air quotes, as possible, but not as flexible as it gets more and more complicated. It has to have its boundaries, but in this scenario, our for loop, the idea behind the for loop is that it handles an array or arrays that have variable number of items. The array could be empty, the array could have 5 items, it could have 10 items, it could have 100 items. That's why we use a for loop, because we don't have to count how many items there are. For loop is going to do that for us. So how many items are there? I don't know. I just know that this I is going to iterate for as long as 1 less than the length of the array. Why? Because the value of I starts from 0, but the length starts from 1. So length is 1 higher if I goes as much as the length of the array. Since I starts from 0, the last iteration is going to be undefined. We don't want to have that because that's not going to be included within the array. So you could say like this, you could say I is going to be 1 and I is going to iterate for as long as I is equal to the length of the array. But the convention is like this. So I'm going to go like that. 1 less than the length. So if length is 6, what is the final index of that? Like here, the length of this array is 5. What is the index of the last item of the array? It's 4. Why? Because indices start from 0. So 0, 1, 2, 3, and 4. So you can see 4 is 1 less than 5, right? And let's get started with this. Now, how do we go about this? Well, we need to first store what I selects. If I selects 10, well, I need to store it somewhere so I can manipulate that. If it is 4, if it is 2, let's just store it somewhere. And since I don't know what the type of that is, it could be a number, it could be a string, I'm just going to say that's an item of an array. And how do we select that? Well, we grab our array and we iterate over it using I. And the way this works is, so if let me just pass an I again. So in the first iteration, what is the value of I? It is 0. And if I'm passing this, so take a look at this syntax. You need to be familiar with this. What is this? What is this going to give us? This is going to give us the item of this array based or situated at the index of 0. And which item is that? That's the first item of the array, because the first item of the array is located at index 0. And in this scenario, this item is going to be 10 in the first array, but it's going to be different for different arrays, right? And since we don't want to hard code it, we just say, okay, I'm going to select my array and I'm going to select one item from that array based on its index. And which item is that? Well, that is going to be the job of I to define it. We could log this, but it's going to get way too crowded inside of our console, so I'm not going to log this. Now, what we did in JavaScript was we checked if this item is not an empty string and it is something that can be converted into a number. it's either a number or something that can be converted into a number. So I'm going to say if, the same method, if isNaN returns false, that means it's a number. So I'm going to pass an item there. But keep in mind, I'm passing the item, not this, because I already stored this individual item of the array inside of here. Well, I could have passed that here as well, this array I, but then I don't have to do it. It doesn't really make sense. I need to store it somewhere so I can access that value in different iterations. So if it is convertible into a number, aka it's a number, or and I could say and it is not an empty string, this means that we got a number, right? So I am going to store that inside another variable and I'm going to call it number. Why? Because at this point I have a number. If it is a string, it's not going to be inside of this if statement, inside the block of this if it is a string. It can only penetrate this if this is a number. So since I don't know if it is a number or if it is something that can be converted into a number, I'm going to convert everything to a number. So I'm going to grab that specific item that has passed through to the if statement. I'm going to convert it to a number. So we have found our very first number. And in the first iteration, what is this? It's 10. So let's just keep passing that, right? So I'm going to pass in 10, and this item is going to be 10, right? And you know what? I could just leave that as it is. So I could just say 10. I could just say item. So this item is 10. So here we have 10. We know that this is going to return true. This is also going to return true. So we jump inside of this if statement. We convert 10 to 10, and then we store it inside num. So what did we do? We just hit our very first number. So when we have our very first number, does this flag hold true? Yes, it does. It's no longer false because we found our very first number. So I'm going to say has valid numbers, but I'm going to flip this. This if statement is only going to work if we do not have valid numbers. And why? Because remember, our initial value for the max, that's 0. That's our starting, or that's the base of our comparison. But in the first iteration, we have 10, right? Now, what I'm going to do is I'm going to swap the value of 0 with 10. I'm going to update our max with the first number that it finds. And then that's going to be the base of our comparison. All right? So here, what I do is I select max and I update it with the current value of num. And what is num? Num is basically 10. So if I pass in num, that's going to be 10 for us. Now, since I have found a number, what am I going to do? I'm going to set this to true. Now, this max, again, the reason that I did this is because we initialized max to 0. And why did we do that? Well, we did that for a very good reason. And the reason for that is because if I just get rid of this, if I just get rid of the first initialization, what do you think is going to happen? Well, in no scenario, we are going to have any, in no situation, we're going to have any value for our number. I am going to come back to this getting rid of the 0 part, but for now, what you need to take away is before the start of our for loop, the max's number is 0, the max's value is 0. But once we get to our very first number, once we hit our very first number, now keep in mind, if this item were to hold a string, we would not even jump inside of this if statement. So none of this matters if this is a string. This only matters if this is a number. So if this is a number, what we do is we update the value of max with that number. And in the first iteration, what is the value of max? It's now 10. And I've basically set this flag to true. I've set this state variable to true. And now if it is true, do we go inside of this if statement in the next iteration? So if I'm talking about this array, the next iteration is going to be 4. So item is going to be 4. And 4 is going to pass this test, and we're going to store it within num. But is this if statement going to be breached by 4? No. Why? Because we said the value of has valid numbers to true. We set that to true. And in here we say, we jump inside of this if statement only if has valid numbers is set to false. But we updated that to true. So we skip this. Why do we skip this? Because we need to go somewhere else. We need to compare two things. So I have max, which has an updated value of 10. And I have num. What is the updated value of num? It is no longer this 10, it is 4. So this number is actually 4. And I'm going to say, is 4 greater than 10? Is it the case? No, it's not. And when 4 is not greater than 10, we do not calculate whatever comes inside of this if statement. Sorry, inside of this else if. So we essentially get out of this giant if statement here, and we go to our next iteration. So in the next iteration, we have 2. And we know that item is going to be true. 2 is going to penetrate this if statement. We're going to set this num to 2. Let's just set it to 2. And do we go inside of this if statement? No, because this flag is still true. We didn't set it to false anywhere. We didn't reset its value. And then we have this else if. Do we go inside there? No, because we know that this num is 2 and max is 10, right? Is 2 greater than 10? No. Let's go to the next iteration where I has a value of 0, 1, 2, 3. So the value of I is going to be 3. And in this iteration, we have 23. This is interesting. So we convert 23 to 23, and it's not going to be able to penetrate this if statement. But what about this one? So we know that num is 23. Is num greater than max? Yes, it is. So whenever we find something that is greater than max, we immediately update the value of max. Why do we do all of this? We do all of this not to use the math.max method, this max method. So we do all of this logic, all of this back and forth, not to use that method. Now, in the next array, this is going to be empty. In the array after that, we have strings. In the array after that, I don't even have like 5. I have like 150. I still have 10. I still have my 23, but then I have 150. So is it okay for me to hard code these values? No. So I need to do this programmatically. I need to do it in a way that it can handle all things for me. So this is our item, and the item, it could be anything. And I try to convert it to a number here. I'm going to pass an item there. Very good. And then what is it saying? Is not assignable to type number. Type string is not assignable to type number. The reason that it is saying that is because this item, it could be a string, right? I am going to come back to it. So for now, this is already not hard-coded, but what about this? So this is going to be num, and this is going to be max. Why num and max? Why not the other way around? Because when we store something inside of max, we're looking for anything that is going to be greater than that stored value of max. So this is how you show that, right? And if num is greater than max, then we are going to set that to max, all right? So, and let's just forget about this for now. And I wanted to show you if I were to get rid of this 0, what is going to happen here? I just got rid of that and I got another error. And this error basically says that you didn't specify the value for this max. You didn't initialize that. So if I go over this, you can see it says we're using max before being assigned, because I didn't give it, I just initialized this. Well, these terms, these are sometimes confusing for me. What this basically says is whenever we write let, And max, which is the name of the variable, that's initialization. But assignment comes whenever we pass in this assignment operator and some value in front of it. Since we don't have the assignment operator, we're trying to use the value of a variable, which is called max, before it is being assigned. That's the problem. That's why you need to assign it an initial value, so then you can actually use that, right? Now, I am going to get out of our for loop. We still need to have that message. If we don't have anything inside of our numbers array, then we want to return this as string. But we don't have any numbers array. How do you go about this? Now, imagine if you were iterating over an array that has strings. What would happen? Well, this item would be hello, for example, apple, right? So item is apple. This if statement is not going to hold true, so we're going to skip this entire code block. And then we're going to go to the next iteration. In next iteration, this item is going to be banana. And then this if statement is not going to hold true, so we're going to skip that. All right. And then what just happened? Well, this flag is still false because this flag is set to true. And as this flag is going to be set to true when we hit our very first number. But do we have a number inside of apple and banana inside of this array? No, we don't. So this flag remains false. And I'm going to say if has valid numbers is false, meaning I need to flip its value, then I need to return this message. And what if we have numbers? Then we just return max. Save that. And you can see we still have this error. The reason for this is, again, this item in a mixed array, like this array right here, it could be a number and it could be a string at the same time. So what we need to do is we need to get rid of this error. So I'm going to convert this into, I'm going to say if this is only a number. There we go. And we got rid of that. So you might say, okay, you have redundant code. This is just the conditional part of the if statement, and this is the actual calculation. So on line number 11 here, we have this is the conditional part of the if statement. But on line number 12, this is what we actually calculate and store inside of a variable, right? So that's why we repeat it 2 times. Just get rid of that. But I can't type annotate item because it could be a number and it could be a string. If I say string, if I say just numbers or just strings, then this entire challenge doesn't make sense, right? And that's it. That's our single pass algorithm where we calculated everything, in just one go, in one pass. We calculated everything. And then we return our max. So to just go over this very quickly, you can just skip this part. I'm going to try to go over this extremely quickly. So we store in every iteration for any array. We know that the array has some items because if the array is empty, we're not going to even get to this for loop. So we grab every individual item of that array. We store it inside the item. We check if that's a number or something that can be converted to a number. And if that's not a string, then we store it within this variable, which is num. Now, I am going to update the value of max with this num. So in the first array, this num is going to be 10. And if I set max to 10, max is going to update its value from 0 to 10. Okay. And then I turn on this flag because I no longer want to come inside of here. And I need this flag for this message as well. Because if this flag is false, if this has valid numbers is false, we're not going to see, even if we have numbers inside of our array, we're not going to see that. We're going to see this message because this comes later inside of our code. You can see this is on line 23 and we're going to see this message. Okay, so we update the value of max with num because we need a basis for comparison. Our very first basis for comparison, which was basically just for assignment purposes, was 0. Our updated basis for comparison is 10. So now the value of max is 10. we take a look at the entire array items, every one individually, and we need to find a value that is greater than 10. If any such value exists, we update max with that value, like 23. But if we didn't have 23, the value of max would remain at that base comparison, which was 10. Because we didn't find anything larger, we wouldn't have found anything larger than that, signifying that that 10 is the largest number. So this is how this entire thing works. It's extremely simple. It is extremely simple. And then we need to run this just to make sure that it works. TSC btab, and then clear it again. I'm going to say node btab, hit run, and there we go. So here we are. We have 23, we have 0, we have our message. We have 150, we have 12, and then we have 4.7, as expected. With this, the solution for TypeScript has come to an end. Let's jump into Python. For the Python solution, the first thing that I'm going to do is define our max function. This is going to accept an array. And so what do we want to do here? The first thing is we need to check if this array or list, it has nothing inside of it. So if length of this array is equal to 0, that means we want to return 0. And now that we have checked our empty array edge case, we need to, what we are going to do is something much like the JavaScript solution, where we created an array and we populated that with only the numbers. We're going to use the isInstance method, and I'm going to pass in something that is going to be used to populate our array or our newly created list. And that thing is going to be num. But this num is only going to populate the newly created list if it has one of the two types, if it is either an integer or if it is a float. So I'm going to select this entire thing, surround it with square brackets just to denote that this is a list. And now we need to iterate over all of the array items. And in each iteration, we are going to make this check. We are going to do this check. If number is an instance of either integer or float, if this num, then we are going to put it inside of this list right away. So we're going to say num for num in array if this condition holds true. And this is extremely simple. This is very easy to understand. So what we have here is we have this num, which you can think of this as our variable right here. And then we have this num, which is the same thing, but then this num goes inside of this array. And in each iteration, we check this condition in each iteration. So if this condition holds true, that means we take a look at num and it's either an integer or a float, then we put it inside this entire thing, inside of this list. And you can think of this as a list comprehension. And now I need to store that somewhere as well. And I'm going to say numbers. Now, if this returns an empty list, that means we didn't find any numbers and we just had strings. And then we need to show our message. So if the length of numbers is equal to 0, what does this mean? This means you need to pass numbers. There we go. And now that we have handled this edge case, what if the numbers array, it contains items? Then what do we want to do? Well, in here, what we did was we iterated over all of the items and we created a numbers array. Now, we need to take a look at, we need to actually handle the edge case where we have strings and numbers within the same array. So I'm going to say for item, since I don't know if this item is a number or a string inside of our original array. Now keep in mind, we are still referencing our original array. The reason for this is inside of the numbers, we have extracted all of the numbers. But what if we have a number that is surrounded by quotes, like our 150? Then we need to convert that to a number and we need to put it inside of the numbers array or the numbers list as well. But for now, you need to know this, that if you just want to if you know that the user just passes a list of numbers, up until here, you're done. The solution is going to be over. But what we do after the fifth line is to handle if there is only strings or if there is a mixture of strings and numbers, and if there is a number that is surrounded by quotes. So that's why we do this. Now, that's why I call this item, because it could be a number on its own, or it could be a number within a string, which is technically a string, right? So I'm going to say if, let's grab our is instance, if this item is of type string, I'm selecting all of the strings, and I'm taking a look at every individual one of those strings. And I'm basically looking if I can convert it to a number. So how do I convert it to a number? I could select either the integer method and I could pass in the item, or I could select the other method, which is called float. But I'm going to select the integer method. And I'm going to select the integer method, convert this item to a number. Now, if the string is apple, I can't do this conversion. And then I'm going to end up with an error. I'm going to show you how to get rid of that error, how to handle errors as well. But for now, let's just assume that we have 150 a string. So I convert it to a number 150, and then what do? Well, I need to put it inside of the numbers array. So I am going to call the append method on the numbers array. There we go. So I put it back inside of the numbers array. And let's just save it. Let's move forward. Now, we know that our numbers list, it just contains numbers. And it also contains all of the strings that could be converted to numbers. Now, how do we find the maximum? Well, we have this max method in Python, and we need to pass in our list of numbers, and this is going to return the largest number. And that's it. Let's take a look at our edge case, our blocks here. Instead of all of these, this is going to be print, and let me select this comment. We have this sign and find max. Let me select that. This is going to be _m. And let's save that. Now, let's run this. Clear Python C tab, enter. We get this error. Why do we get this error? So when did we get this error? That's more interesting than why we got it. So for the first case, which was normal array, like this. So let me select it. So this is our normal case. And you can see the biggest number is 23. And our normal case actually worked. Okay. Then after the normal case, we have our empty array. That one worked as well. All right. Then we have apple and banana, and we got this message. It worked as well. Why did it work on apple and banana? Because we went to this if statement. And when we return on line number 8, we basically get out of the function. We complete the function call, and that's it. We don't go and proceed to line number 10. So the first 3, they're okay. When did we hit a problem? The problem rose when we had a mixed array. Why? Because there is a number and then there is a string. Why do we hit a problem? Because we pass in all of these and we get into this for loop. And then we get into this is instance. And we take a look at an item that has a type of string, but we cannot convert it to a number. So where is the actual problem? Is the actual problem 10 right here? Is it the 10? No, it's the hello. Because hello, 10 is not going to be even come within this if statement, because 10 would already be, so we are iterating over a list and creating a list at the same time. This numbers, in this scenario, it would contain 10, 23, and 5. It only contains all the numbers. But then we have 2 strings, hello and 150. The problem is hello, it's not 150, because 150 is a string that can be converted to a number using this int. It can be converted. But the problem is this hello. Hello is an item that has a type of string, but it cannot be converted to a number. Then it throws an error. And it gives you line 24. There we go. Line 24. It gives you the line number. And let's take a look at unit to pass numbers, and then trace call print file numbers append, and then there we go. Let's take a look at this, and I told you it's the hello one, right? There we go. It says invalid literal for int with base 10 because this is a string and it can't be converted to a number. So we get this error, and we just had one console 2 3 prints. But the error, what it did was it basically prevented our app to go to the next line, go to this one, and to go to this one, to the final 2 print statements. So what we need to do is we need to handle this error, and we can handle it extremely easily. I'm just going to cut this, and I'm going to pass in a try except block in Python. This is going to be except. So we're going to, whatever the expression it is that we want to handle, we put it inside of the try. And if there are any errors, we put it inside of the except block. So if there is, now what kind of an error this is, we need to specify that. So there we go. It says it's a value error right here. See, it says it's a, let me show it to you like this. It says it's a value error. So I'm just going to copy this value error. I'm going to say, except this value error. If you hit this value error, then just say pass. Don't do anything. Don't print all of this. Just pass. And this keyword, this is the reason for this is any block in Python, it has to contain something. And if I want this except to do nothing, then I should not include anything in here. But then the problem is that this is a code block, this except, and it needs to have something. And then they created this keyword, and this pass is basically going to denote that this block is not going to do anything. And now if I run it again, we got everything. There we go. Perfect, right? So we got 23 empty array, a message, 150, 12, 4.7. What about the error? We said pass. Don't print it. Don't do anything with it. We just said pass. So that's why we needed this try catch block. And just to go over this one more time, we got all of our numbers already, like for this mixed one. We got the 10, 23, and 5. I could just show that to you. That's easier, right? Numbers. And then I have numbers here as well. Clear this and run it, and there we go. And this is going to show this print statement for as many times as we call this function. Since we call the function several times, it's going to show the print statement several times. But we are interested in the mixed one. So right here, we are interested in this one. And for that one, it's right there. So you can see within the numbers array, I already have 10, 23, and 5. The problem is hello and 150. But the thing with 150 is, that's why we take a look at the string, because we have already extracted the numbers. That's what I wanted to get across. And then I want to talk. So numbers only contains numbers. That's why we take a look at strings here, just to find out if any string can be converted to a number. Since 150 can be converted, but hello cannot be, we basically have this error. And then we say pass on the error. Cool. That's it for the Python solution. Let's jump into the Go solution. Let me close that one as well. And now that you have solved this challenge for TypeScript, for JavaScript, TypeScript, and Python, the Go solution is going to be simple as well. The first thing that we need to do is just import our main package, and then I'm going to define our find max function. This function is going to accept an array, but in Go we don't have, since Go is a type statically typed language, we should specify what the type of this is, and we don't have what we had in TypeScript, like number union string. We need to have either one type for a specific data structure, like for this list, or we need to have all types be acceptable. Now, if you watch the previous challenge for the Go solution, which was also about arrays or lists, I passed in a newer syntax, which was any type. But the any type, if you're coming from TypeScript, that is something that you are taught to avoid. But then in Go, that's the correct type that we're going to use for a data structure that could contain several different types. In our case, it's going to be 2 types, but then 2 types is still one more than one type. So if it is more than one type, you need to use the any type. But then here, what I want to do is I want to use the previous syntax, the older syntax for Go, and that's an interface. So an interface in Go is something that we use in order to type annotate an array or a list based on the different types that the array contains. So this is going to be the syntax for an array. We write the interface, but then what the interface accepts is going to be within these square brackets. And you see these 3 dots underneath this interface. If you hover on it, it says interface, only the interface part, see, not the square brackets, can be replaced by any. And then you can just take a look at this, right? So, but I want to use interface in this one. However, when we say interface, we don't want to return an array that has a type of interface. We want to return one array item that has a type of interface. And why do we do this? So interface, because this interface, curly braces, this is to denote that what is the individual type of any item within the array. So it could be dynamic. That's why it's called interface. Right? And we return one of those types. So we know that we return either a number or a string. That's why we replace number and string by an interface, because an interface could be a number and then it could also be a string. And that's how we go about it in Go, because we don't have those union types here. So the first thing is our check. This is going to look a lot like the Python one. So we check if our array, our input array, has nothing inside of it. If it has nothing, then we want to return 0. So that's the first check. Then what we need to do is we need to actually come up with a way so we can filter out only the numbers. Since we don't have any filter method in Go, we need to implement that manually. So I'm going to create a variable and I'm going to call it numbers. And this is going to be an array of float 64. Because this is going to contain this numbers, it could contain decimal points and numbers with decimal points as well. So float 64 is a better type rather than I64. So we need to iterate over our array and we need to take a look at what the array contains, what the type of that item is, and what the actual item itself is. And for this one, I could use a switch statement, and I'm going to store in each iteration. So let's just copy our test cases, put it right here, and I'm going to convert all of this to Go syntax. So I'm going to say print fmt dot print line, and then I need to create our main function and then put all of that in there. Save this. Let's indent these a little bit. There we go. So we have the switch statement. The reason that we do this is because we need to take a look at different cases. If the type is integer, that's going to be a different case. If the type is float, that's going to be a different case. If the type is a string, that's going to be a different case. All right. And then we need to also take a look at if it is a string that can be converted to a number, much like what we did in Python, right? So here I'm going to create this v, which is going to be short for value. I could just call it value. And this is going to be a short variable declaration. And this value is going to contain one item from the input array in each iteration. So since we talk about iteration, we need to define our loop syntax as well. I'm going to say for underscore comma item. Underscore signifies that this is a black identifier and it represents the index. I don't care about the index. That's why I pass an underscore. That means I'm not going to use it. But then we have this range, which is going to iterate over our array. And whenever we iterate over our array, we are going to check some cases. So we want to check whatever the array contains. So that's going to be one item in one iteration. All right, so we go one by one. The loop idea is the same in all programming languages. So you do one specific thing for all items of any data structure. And that logic has to be the same thing. And it is going to be applied on all items. So taking a look at our first array, we have this number 10. So this value is going to be number 10, right? But then what is the type of that? So what I'm going to do is I'm going to set this item as our value, but I need to select the type of that as well. How do I do that? We have a very special syntax in Go, which is dot type. And this is going to dynamically check the type of the interface item. So what this actually does is it is going to store not only the value of item within our value variable, but it is also going to put the type in there as well. And so we can use it in our test cases, in our different switch statements. So what kind of cases do we have? Since we talk about Go, we have integers, we have floating point numbers, and then we have strings. And then we have strings that can be converted to numbers. So we have several different cases. The first case is going to be integer. And what do I want to do if I hit an integer? Well, if I hit an integer, since our numbers array only contains, we type annotated that to contain float 64 type numbers, we need to convert this integer to a float 64. So I'm going to grab my float 64 and I'm going to pass in this integer right in there. Now keep in mind, when I say case int, I'm not looking at the value at what the individual item of the array is. I'm looking at what the type of that is. That's why we got the type here. So if the type of that is integer, we convert it to a float and then we append it to our numbers. Very simple, right? So how do you append it? Well, in Go, the syntax is a little bit different. So where do you want to append it? We want to append it to our numbers array. And then we call the append method as well. Now, since I appended that to my numbers array, that means I updated my numbers array, and I'm gonna put the numbers right here. So this new variable, this basically the same variable, different assignment, different initialization, this is going to contain all of the integers who have been converted to float 64. So that's our very first case. But what about the second case? The second case is if we hit a value that is already float 64. So if it is float 64, do I want to convert it to float 64? No, I just want to append it to my numbers array. So I'm just going to copy that line, put it right here. I am going to get rid of this float 64 because it already is float 64. Now keep in mind, again, we check the type in these two cases, but then we append the value. We don't append the type. See? We put the value inside the numbers array. We check the type again, but we put the value. So you need to know what it is you're doing. Next case. Next case is if we have a string. Now, if we have a string, we need to take a look at if we can convert it to a number, like our 150. Well, how do we do that? In that scenario, we are going to say if we can convert it to a number, so we do need an if statement. So for this if statement, we are going to have a very special kind of if statement, right? And this if statement, I'm going to pass in a num, something that's called a num, and something that's called error. If the conversion is successful, that means, well, it was successful. There is no need for the error. But like Python, if the conversion was not successful, I want to suppress the error. I don't want the error to be shown inside of the console. So if I don't want the error to be shown inside of the console, I'm going to say error is going to be nil. it's going to be nil. Now, what happens in here? Well, in here, we're going to target a very, very specific method that is called parse float. And what this method does for us is it is going to convert a string into an integer. In this scenario, it's going to convert it to a float for us. So, and I need to pass in semicolon there. So what is it that we wanted to convert for us? Well, we have this value, right? That's our iteration count. And then we want to convert it to a float with a base of 64. And then, now, where is this parse float available? We have this strconv string conversion library that we need to import as well. So let me just import it. I'm going to say import. And now that I'm here, I need to import fmt as well as the strconv, or the string conversion library. This should be parentheses. Let's save that. It's a little bit weird. Didn't format that. So let me get rid of it. Hit enter, and let's hit enter on this one as well. Very good. So we imported string conversion library as well as the format fmt, which we are basically using here. So on the string conv library, we have this parse float, and this parse float is going to convert a string into a float for us. We also have parse int, and the base for that is going to be 64. But then we need to basically assign this to our number as well. And then this num is going to be the number that was converted from a string. And if the operation was not successful, then the error is going to be nil. We are basically suppressing the error. So what if the operation was successful? Well, we need to grab our num and we need to append it to our numbers, right? It's almost like the way we went with TypeScript. The idea is the same, right? We first extract all the numbers, and then we extract all the strings that can be converted to numbers. And let me pass a num, and then we need to update our numbers with this as well. There we go. So I believe we are done in here so far for our logic. Now, what we need to do next is we need to have our message if user passes only strings. Then what do we want to do? So let me just copy that part. Where am I? So loop ends right here. I need to get out of it there. So if the length of numbers is equal to 0, now you can see I have done everything I could. I extracted the numbers. Let me just tab these. Very good. So I extracted all the integers, converted them to numbers. I extracted all the floats. I extracted all the strings that could be converted to numbers. But even after all of this, if numbers is empty, that means we just had strings to begin with. So, oops, I need to pass in return this one. You need to pass numbers, and that's it. So now that we know that the numbers is going to contain some numbers, how are we going to calculate the max? Well, the thing is that we need to do that manually as well. And how do we go about this? Well, we go sort of like the way we went with TypeScript, but it's going to be a little bit different. So for TypeScript, what we did was we initialized the max variable. We assigned it a value of 0. And then we changed, because we said, okay, 0 is the base of comparison basis. But then I changed that with the very first number that I got. And then I said, okay, that very first number is the base of comparison. But then in here, I'm not going to do these two things. I'm just going to do it in one go. I'm going to say the first item within my numbers list, or within my numbers slice, that's going to be the base of comparison. So in the case of the first slice that we have here, which has an item, the first item of which is 10, our comparison basis is going to be 10. The logic is going to flow in the same way, all right? Now, let's iterate. We grab the indices. We don't care, but we want to grab the numbers. And let's grab our range. I'm going to select our numbers array, but something very interesting is going to be written inside of the square brackets. Now, what do you think I'm going to write inside of the square brackets? Why did I even write the square brackets? Well, I made a mistake. This should be 0 on line 34. Max is initialized to the first item or the first number within our numbers array. Why? Because we need to have a basis in order to compare other numbers to, in order to find which one is the maximum, which one is the largest number, right? So that's going to be the first item, almost like what we did in TypeScript. But here, let me get rid of this. This should be this. In here, I said I'm looking at the indices, but I don't want indices, so I passed in underscore. I'm just looking at the numbers or items that I have within this numbers slice. But then I passed in the square brackets. Why? Because we have already selected the first item and we have assigned it to our max. So 10 has already been assigned to this max. So do I have to assign it again? No. So what I do is I say start from the item that has an index of 1. What is that item? That item is 4. Since max already contains 10, like this. So max already contains 10, we are going to start with 4. Is 4 greater than 10? No. Max is going to stay 10. Is 2 greater than 10? No. Max is going to stay 10. Is 23 greater than 10? Yes. Max is going to be updated to 23. And then for the final iteration, is 15 greater than 23? No. So max is going to stay 23. And how do we implement this logic? It's very simple. We say we want to update max only if the number that we have found is greater than max. If it is not greater than max, then max is the greatest. So we just return that, right? And there we go. All of this not to do the max method that we had in JavaScript. But I find this more interesting. And now the only thing we need to do is run this. But first we need to pass in this interface type here as well. So I'm just going to copy this. I'm going to select our functions. Hopefully I'm not going to make too many mistakes. So within the parentheses, I'm going to pass in interface. Now the thing is, this array, it should be converted to an interface as well. Meaning the square brackets should be gone, and instead of the square brackets, we need to have these curly braces. So that's too tedious. What I'm going to do is I'm just going to copy paste my main function from my notes. Just put that there. So if you take a look at the syntax, it's very interesting. We called our function, we pass in what the type it's going to accept. It's going to be a slice. The type of the slice is going to be interface. That's the syntax of the interface. And then you can see instead of square brackets, we have curly braces there. Very good, right? And then if it is an empty array, we just pass in an empty pair of curly braces. All right? So you see how this works. And yeah, we don't see any errors. Let's go ahead and let's run this. So clear. Let's bring it up. Go run the tab. Wait a few seconds. And there we go. So what do we get? We get 23, we get 0, we get our message, we get 150, 12, and 4.7. Very good. Very good. Now, again, you could swap these interfaces with the any type and it would work in the same way. Now let's jump into our final language. But for this final language, as you can see, it seems that we have two different files. We have v1 and then we have v2. So for the first, because the reason for this is Rust is much more complicated when it comes to types than any of the other languages that we're talking about. So if we say that the slice, or in Rust it's called a vector. So if we say a vector contains less strings, as well as numbers, that's going to be a whole different solution than if we were to say that the vector contains only numbers. Numbers could be integers and floats, but nonetheless, they're numbers. And then this is going to be a different solution. So what I wanted to give you was two different solutions. One solution is going to be our V1. This is going to refer to if we pass in a vector or an array that contains integers and floats, no strings, no mixed types, right? But in the V2, we're going to go over if we have strings as well in there, or if we have an array that has only strings, if we have an array that has only integers. So that's going to be the V2. So this is probably going to be the longest part of this entire video, and I honestly don't care about how long it takes. It's just too much fun for me to tweak the solution, to come up with different ways. It's a very good programming practice. And without further ado, let's dive right in. For the first solution, for solution V1, what we're going to do is we're just going to take a look at if the vector contains numbers. So it could be integers, it could be floats, but nonetheless, they're numbers. And the way I'm going to go about this is I'm going to define a macro. So it's going to be macro. Some things that I'm going to do here, they are based on the syntax. They're required for the syntax of the macro. And other things are related to our challenge. And I'm going to tell you which parts are which. So this macro rules, this is part of the syntax. Then what a macro requires is a name. I'm going to call this find_max. That's going to be the macro name. And this macro is going to handle only one scenario for us. And that scenario is if the vector that's been passed, it contains some elements. And those elements should be numbers, integers or floats. But we're not going to talk about if the vector is empty, if it is mixed, if it contains only strings. That's the solution number version 2. This is just simple solution, all right? Now for this one, since we want to talk about a specific case within our macro and we want to define a rule here, there are some syntactical parts. This is the part of the syntax. We are going to have double square brackets for our syntax, and these double braces, they are going to be used to isolate the expansion scope from the surrounding code. So the only reason that we have two curly braces is because we want to really be sure to separate this from the other parts of the code. So what happens here? What happens here is we have this pair of parentheses. In here, we're going to write something that's called a pattern or an expression. And however this pattern works, we're going to generate something in here based on that pattern. So what is going to be that pattern? First, let's write the pattern so we understand what the pattern is, and then we're going to take a look at what it actually tries to generate for us. So the pattern is, first, the type of the pattern. What should be the type? We know it's an array, list, slice, or vector, so we need to pass in square brackets. Then, this pattern is not going to be for one item. It could be for 2 items. It could be for 3 items. I don't know for how many items this is going to be. I don't know the input vector contain. How many items does the input vector contain? I'm not sure. But I want to repeat it for as many items as there are within that vector. So I need to have some sort of a repetition syntax, some sort of a loop. And the way we do it in a macro is we have this $sign parentheses. So within the parentheses, what we say is repeat this 0 or more times. So you can repeat it 0 times, 1 time, 2 times, 3 times, however many times there are numbers or there are items within our vector. What do we want to repeat so many different times? Well, we want to repeat something that's called an expression. Why do we say an expression? Because I'm not sure if that's an integer or that's a floating point number. So the way you define an expression is you say expr, but then you need to signify this to the Rust macro engine. using this dollar sign, and then what should be the name for this expression? I could call it x because this is still going to be a number, or I could call it m, n, I could call it y, I could call it v, whatever I want, but I need to be consistent. So if I call it n, short for num, I know that this is a number, right? Then I'm going to use num in our further calculation. That might be confusing. I'm just going to pass an x. So what this basically means is we have a meta variable named x that is going to match a single expression. All right, and this meta variable is going to contain the values that come from our input vector or input array. Temporarily, this is going to contain that. All right, now we want this expression, this entire expression, to be repeated 0 or more times, but we want it to be separated by commas since this is a vector, right? So we pass in a comma and I pass in the star. This means repeat the inner pattern 0 or more times. Now, you could have added some other alternatives like the plus sign, which means 1 or more times, or you could have passed in the question mark, which means 0 or 1 time. But since I want to say 0 or more times, because that's going to be our repetition pattern as well, I'm just going to pass in the star. And that's it. That's the pattern. So why do we need this pattern? This pattern is just so it goes inside of our input vector, the array that the user passes in. It takes a look at every individual array item and it checks if that's a Rust expression. It could be a number, it could be a float, and then it puts it within the x. Keep in mind, temporarily x is going to contain that. So how do you extract that value from x? Now keep in mind, we need to specify a big type. So if we have an integer and if we have a float, even though both of them are numbers, technically there are different types. One is an integer, one is a float. So we need to decide what is going to be our big type. Do we convert all of the numbers to integers or do we convert all of the numbers to floats so we can show it in the console? Well, if we convert it to an integer, the float numbers, they're going to lose their decimals. But if we convert it to floats, floats are going to be floats, decimals are going to, integers are still going to be in an integer. So float is going to be better. So we select this x and we convert it to a float. So I'm going to say f, let's cast this as 64. Oh, not 54, 64. Now, once I did this, I want to populate a new vector with this because the first part that I did, that's the pattern. It doesn't do anything else. It's a pattern that takes a look at every individual item. It puts it inside of the x and it adds a comma in there. And it selects the other item in the next iteration. It puts it in x and it adds a comma. So that's that. But then I need to populate my array with that as well, or my vector. So here, what we need to do is we need to surround this with square brackets because that is the syntax for a vector. So how many items are within our vector? We don't know. So we are going to repeat this for as many items there are. And we want to repeat it 0 or more times, right? So we need to have our repetition pattern, which is $, parentheses. There we go. So we repeat it as many times as there are items within our input array. But then do we want to separate this by comma? Yes, we do. There we go. But now keep in mind, we are within a macro and we want to create a vector. How do we do that? We can use the vec macro to create that for us. So this vec macro, this is going to basically create a, technically what this does is as follows. So what this creates for us is this vector using a trait implementation, it is going to create a vector for us, right? But what you need to take away is this vector is going to create, this vec macro is going to create something that looks like an array that we can put inside of this variable. So this ARR, that's our array. That's our vector that this vec macro has created for us. Now, after it has created that for us, I know what that is. Can I iterate over it? Can I iterate over this ARR, array? Yes, I can, because this is a vector. I mean this. Can I iterate over this? Yes, because this is a vector. So let's iterate over it. Before iterating over it, what is the main thing about this challenge? We want to find out what is the maximum, right? So I am going to create a variable and I'm going to call it max. And we need a basis for comparison, right? So the basis for comparison is going to be this first item of the array. Now, if I want to make this challenges solution look more like the TypeScript and the Go one, I could replace this array with the numbers, because at this point we already have numbers. We don't have anything else. So we need a basis for comparison, and that's going to be the first item of our numbers vector. And in the first case, that's going to be number 10. And then in the second case, it's going to be 4. In the max is not going to be 4. The next item is going to be 4, right? And then it's 2. But when we get to the iteration, which is 23, we need to update the value of max. So we need to, in Rust, we need to specify that this is a mutable variable, meaning, in simple words, it's something that changes. That's what it means. Let me terminate that as well and terminate this one. Where is our loop? So we're going to say for num in what? In what? In numbers. Now, for num in numbers, what do we want to do? We are looking at if num is greater than max. So max initially for our very first vector is 10. In the second iteration, num is going to be 4. It's not greater than 10. In the third iteration, num is 2. It's not greater than 10. In the fourth iteration, right? Yeah. In the fourth iteration, num is 23, which is greater than max. Then we update the value of max with num. Let's terminate this as well. And finally, let's return max. So you need to make sure that you're outside of the for loop. And I just returned. Let me put this on the next line, indent it. This should be like that, and close this one. If there are any errors, we're going to fix that. And we should be good to go. So for the test cases, I just added 2. We have this 10, 4, 2, 23, 15. And we call, now this find max is actually going to be a macro. So whenever we call this, we need to pass in the exclamation mark, signifying that this is a macro. Let me say Rust C, E tab, hit enter. We seem to have a problem. It says attempted to repeat an expression containing no syntax variable matched as repeating at this depth x, because x doesn't exist. X doesn't exist. It is $x, because we need to signify. So you can see why this is important, because we need to signify to the Rust macro engine that this is a meta variable. That's why I threw that error. Let's run this again, and now it compiled. Let's run that, and there we go. So in 10, 4, 2, 23, 15, we got 23. And in here, we can see this 80.9 is the largest number. There we go. So with this, the first solution has come to an end. If that's the only thing you're interested in, you can just pause the video here and go about your day. But I highly advise against that. Let's just jump into our second version of solution, because the second version of the solution is way more interesting than the first one. But before getting started with our second version of the solution, we need to really know what it is that we want to do when it comes to V2. So in V1, we said we can just handle numbers. It could be decimals, it could be integers or floating point numbers. But in V2, we want to handle strings if there is a vector of only strings, if there is a mixed vector, so strings and numbers. So that's why we need the second version of the solution. And these V1 and V2, there are going to have some similarities when it comes to the macro pattern right here. that we have defined. And there are going to be some similarities when it comes to the macro expansion block or the expression block or expression body, which is whatever is inside of these double curly braces. So since there are going to be similarities, I'm still not going to copy paste any code from V1. We're just going to get started from absolute scratch with V2, and I'm going to explain all of that step by step. The first thing that I'm going to do here is I am going to define an enum, and I'm going to call it element. The job of this element is to accept the different input types. So we said that whenever the user puts in an array, that array could have numbers. So number, right here, and that array could also have strings. So let me just pass in strings here. So since we're in Rust, we need to specify what kind of a number. Now, I want this number to be one type, but I want it to include both of the types. So if I take a look at my V1, you can see we used an F64. So that's a floating point number, because floats, they could contain floats and they could contain integers. That's why that's a better type than, let's say, I64 or N64. So that's going to be our number. And for strings, we are going to just say that they're owned strings. So this is our element. Now, why do we need this enum? Because this is going to define the input type that we pass into a function that we are yet to create, right? So the input type could be number, could be string, or it could be a mixture of both of them. And then what we are going to do next is we're going to define some traits. These traits, the idea behind these traits is they're going to handle automatic conversions for us. So if user passes integers and the integer, it doesn't have any decimals, so that's an integer, right? And then you need to convert that to an F64 because that's what the function needs to accept. All right. What if the user passes something that's a slice of string? So a string slice, you need to convert it to an owned string. So you need to do these conversions because at the end of the day, the function should only accept a number, F64, and an owned string type. Only these two types. We have something in Rust that's called a trait implementation. And using this enum, we can basically come up with some sort of a function that is going to handle this implementation, this conversion for us. So the way we are going to go about this is, first we define the syntax of the trait. So there are some things, again, that are going to be part of the syntax. So implement, IMPL for short, that's part of the syntax. Now, you need to pass in a type that this trait is going to accept. What type is this going to accept? Now, let's think. I have an integer type that the function could accept. That's one. I have a float type that the function could accept. The input array. So that's two types. I could have an owned string and I could have a slice string, a string slice. So there are 4 types. That means I need to have 4 trait implementations. Let's start with the first one. So for the first one, I'm going to say if user passes any integers inside of the input array, I want to convert it for my element. How do I do this conversion? Well, I have this from function inside of this trait implementation, which accepts something from the user based on what the user has passed within that input array. And we know that has a type of I32. It's a 32-bit integer. All right. And then we want to convert it to the element. So in here, I could write element or I could write the self keyword. And how do we do this conversion? Well, we select our enum on the enum. So if you want to take a look at associative methods for a specific data structure, in this scenario, this enum, you need to do : in Rust. You could technically, this is not correct, but you could think of this like the dot notation in JavaScript. So we have this element. On the element, we have a method that is called number. So number accepts all of the numbers, both types, floats and integers that user passes inside of the input array. So what is this that the user has passed? User has passed num. We know num has a type of i32, so we need to cast the type, so we change it or we convert it to f64. So that's what this enum is going to do for us. And in this way, we're going to basically implement all the other enums as well. All the other trait implementations as well. So this is the first one. Let's jump into the second one. So we say what type it is that we want to select from, right? That's why it says from. So that's the input type the user passes into the array. And then for is the type you convert to. So which type you accept. Let's say for the since we want to move forward cohesively, I'm going to say the second one is if user passes a decimal point, a number that has decimal points, aka floating point number. And we want to convert that for element as well. So we have this from function. It is going to accept a num. That's the function parameter. The type of that is going to be any floating point number. And we want to convert it for the element. How do we do this conversion? Well, we select our elements. Now keep in mind, all these implementations, all these traits, they need to funnel back to that element, because that is going to be what we use to basically type annotate our function, the function parameter to be more exact. So all of these traits, they should go back to their root, which is the element. So on the element, again, you can see I'm using the same number because all numbers, they should go and their type should become f64. Now for this number, the type is already f64, so I don't have to do any conversion. So I just pass that there. You can see here, the type of num is f64, and that's what this trait is going to accept as well. And we can see this is what the element requires as well. Now here we did the conversion because the type was i32, integer 32-bit, and that was what the implementation also accepted. So we converted that to f64. But since this is already f64 and this element requires that, we don't have to do the conversion. So that's the second one. So let's think about this. Have we covered both of the number scenarios? Yes, we have covered integers. We have covered floats as well. So what is the other scenario? Well, the other one is strings, right? So when it comes to strings, we have two different types as well. We could cover both of them, right? So one is a string slice, but what do we want to convert it for? Or what do we want to convert it to? That's going to be the element. Let's grab the from function. This is going to accept str as a function parameter, the type of which is going to be a string slice. We need to convert it to element. Now let's select our element. On the element we have, now we no longer talk about numbers, so we need to select the string method that we got. Now, what does this string method need? Let me pass in the second colon as well. So what does this string method need as a parameter or as an argument in here? It needs something, some kind of a string that has a type of capital S string, an owned string. So we need to grab our str and we need to convert it to an owned string because that's what this function needs. How do you convert it? We have this to_string method, which converts any string slice to an owned string. And let's take a look at this. So this string method, it needs an owned string, and we passed in a string slice and we converted that to an owned string. So this is okay. Let's move forward. And for the final one, I could just copy paste this. So we handled in a string slice. For the next one, we might have something that's called an owned string, and we want to convert that as well. We want to basically make sure that it goes through our enum element, our element. So here, now the type of this is already an owned string, so I don't have to do this conversion anymore. It's exactly like what we did for f64 type number. That's what we do here. So two types are going to be different. like I and string slice, but two types are going to be what we have already defined inside of our element. But so far what we have done is we have just specified what the function accepts. We have not specified what the function produces. And what function is it that I'm talking about? It's the function that's going to do the calculation for us to find the maximum, right? So we said, okay, now the function can accept all these types, but what does the function produce? Well, the function produces either a number, which is going to be the maximum number, or something else. And what is that? That's a message. Like you need to pass numbers. If user passes a vector of all strings, then we need to show a message, and that message type is different. So what we can do is separate this logic. So we had separate logic for handling what the function accepts, aka what the user passes inside of the input array. And then we could have a separate enum about what the function produces, aka the output to the user. So we could call this max result. Yeah, I could call it max result. And we could either produce a number or we could produce a string. So it's up to you. Do you want to convert the number back to an integer in which you're going to lose decimal points, or you're going to keep the number as f64, same thing as inside of our element, so there are no issues in there. And then when it comes to the string, we no longer have the string. Instead of this, I'm going to say message, because I think that's more appropriate, right? But the type of this is going to be an owned string. So the function could only produce a number, which should have decimal points, and then or a message, right? And now it's time for us to actually define our function. So the function is going to be find underscore max. The function is going to accept some sort of an array. The array type is going to come from our element, but we are going to say this is a slice of that element. But what does the function produce? The function produces something that is going to come from our max result. All right. Now, when we talked about other languages, what did we do first? We handled an empty array case. So here I can say if array is underscore empty, then what do I want to do here? Well, I just want to return max result. And then, so we said if array is empty, we want to return 0, right? So now keep in mind, when we say we want to return something from the function, that means we're talking about our result enum, right? But when the function accepts something like the input array, we talk about element enum. Okay, so here on line 37, the reason that we're doing this max is because the function is returning something. And we said the function return type should include a part of this max result. So if we want to return a number, which is 0, so we need to select our number method. So this is going to be number. But what do we want to return? We want to return 0. But is 0 the same type as f64? No. So we need to do 0.0. So that's the first edge case. And now let's think about how we want to go about this. In previous languages, what we did was in the ones that we didn't have any kind of filter method to filter out all the numbers, like the way we did in TypeScript and in Go, what we did was we created a variable that would hold all the numbers within the input array, and then we iterated over that and we found what was the maximum based on some other variable, right? So here we can do the same thing. We can specify a mutable numbers array or vector, and this is going to be empty initially. So this is going to be a new vector because we want to populate this with only the numbers from any input array that the user has passed. And since this is going to be an empty vector and we want to populate it in the future, aka we want to make changes to it, it should be a mutable reference. Now let's create our for loop. So we are going to say for item inside of our array. Now, why do we call it an item? Because we don't know whether, at this point, we don't know whether that's a string or that's a number. So we're just going to call it item. And in here, what do we want to do? We want to match an item to a specific type. And the first case is going to be if the input array's item is a number. So keep in mind, we are within this for loop. And in each iteration, we select one item from our input array. The first scenario that I'm going to handle is, what if that item that I've selected has a type of number? Since when I'm talking about the input array, you can see I'm using the element enum. But when I produce something from the function, then I'm going to use the max result. Now, this is, again, still the input array. So, and we talk about when it is a number. If it is a number, I'm just going to add like this num as a placeholder for it. And then I want to convert it to something that is a number, and then I want to put it inside of my numbers array, inside of my numbers vector, which is empty at this point. So I'm going to select my numbers, and I'm going to say push, and I'm going to pass in num in here. Now, the problem with this syntax is that num is actually a reference to that specific item in the current iteration of our loop. What we need to do is we need to actually go ahead and dereference this. Why? Because we are actually moving the integer inside of our numbers. We don't want to basically pass in a reference. Let's say the first array is this array, right? And in the first iteration, we select number 10. But what we want to do is we want to pass the actual number 10 inside of, we want to push that to our numbers array. We don't want to push a reference to it. So what we need to do is we need to pass in the star, this star. This is going to, what this is going to do is this is going to dereference num for us. And dereferencing basically means get the value. So we get the value of num, we push it to our numbers. All right. You could think of it like num could be a box with a number inside of it. And if you say star num, that's basically opening the box and taking out that specific number, which is within the num box. All right. So we want that actual number. That's why we need to dereference it. So that's our very first scenario. Let's move forward with the second one. In the second scenario, we have if the input is a string. And that's it. We just have two scenarios. Why do we have two scenarios? Because we have already implemented all of the conversions using our trait implementations, and our element, it just has two members. It has a number member and it has a string member. We handled the number one. Let's handle the string one. The string one is going to be a little bit trickier. The reason for it is because the string could be convertible to a number, or the string could be just a simple string and we don't pass it inside of our numbers array. So we need to try to convert a string into a number that has a type of F64. That's why it's a little bit, it's going to be a little bit tricky for us to be able to handle this. But first, the syntax. So in the second scenario, we might accept something that is going to be a string, but how is this going to work? How are we going to implement this? So for this one, we're going to do an if statement. So how do we do this if statement? Now, the syntax for this if statement is going to be a little bit special. It's going to be a little bit unique, but I'm going to go over what every piece actually means. So we want to get our string when we want to see if we can parse it as a float, as an F64. So let's get our string. So we have this string, and on the string, we have this parse method. And the parse method, now, since we want to parse this, we need to make sure that we type annotate this correctly. So how do I want to parse it? Well, I want to parse it as an F64. And if this operation is successful, I want to store this inside of a variable, which I'm going to call num. And let me initialize that as well using let. Now, what is special about this is something that I'm just about to talk about here. So we have a method that is called OK, and this method is special because this is only going to run if this conversion from string to F64 is successful. So take a look at our 150, right? Remember that 150 is a string of 150. Even though it looks like a number, it has a type of string. That is going to pass that test, this conversion for us. And then we are going to store it within our num. But what if we have some string that cannot be converted to a number? Do you want to store that inside of num as well? No. So what we are going to do is we're going to wrap this num with that OK method. So OK method is only going to parse our string if that string actually contains a number, and then it is going to store it within the num. And this is why I said this is a little bit of a special syntax. So again, just to go over this, what we did first was we said, okay, I have this input string and I want to parse it as an F64, and I want to store it within a variable that's called num. Now, if this string cannot be converted to a number, then there is going to be a problem, right? So what I said was, I said, okay, I am going to have this OK method, and the job of this OK method is if this specific string in this current iteration of our for loop, it can be converted to F64, then this OK method should put it inside of num. If it cannot be converted, then the OK method should just exclude it or just ignore that. All right. Now, if we get inside of the if statement, that means one thing: the operation was successful. If the operation is successful, what do we want to do here? Well, we just want to push that specific number to our numbers array. And now let's move forward. So we have completed our for loop, and the next logic that I want to handle is if the numbers array is still empty. And in what scenario is the numbers array still empty? So if after all of this, there is nothing inside of the numbers, that means we just had strings inside of the input array. The input array cannot be empty because we already handled that scenario. So at this point, line 40, there is something inside of our input array. But if it cannot be converted to a number, that means they are just strings. And that means the numbers vector is actually empty. So I'm going to say if the numbers vector is empty, just return something. Now, I'm saying return something from the function. Which enum should I use? Should I use the element or the max one? Well, the max one, because I'm talking about the output from the function. The input to the function is element. The output from the function is the max result. And which type? Of course, the message one. And what message do we pass? We could just copy it from here. You need to pass numbers. Let's just pass that in there, and don't forget, you need to convert it to an owned string as well. There we go. So what is left? The only thing that's left is basically taking a look at our numbers vector and finding which number is the maximum. So after this if statement, if we get to any other line of code, the only possibility is that there are numbers inside of our numbers array. And what we need to do is find what is the maximum of those. And the final thing that I want to do in this function, in this find max function, is to find the maximum. So at this point, we know that we have numbers inside of our numbers array, and let's find the max. So I'm going to create a variable and I'm going to call it max, and I'm going to try to do all of this on one line. So how do we go about this? Well, we grab our numbers array or numbers vector and we iterate over it. So this iter method, this is going to create an iterator over all the elements inside of the numbers vector. But keep in mind, this is going to make sure that all of these are references to the numbers that are within the iterator. So now that we are iterating over the numbers array, let's try to find which number is bigger than its neighboring item. Which item is bigger than the item right next to it? And for this one, we are going to use a method that's called float. And this is going to be a method that's going to accept an anonymous function, aka closure function in Rust. So what is this float? This method is going to start with an initial value. You could think of it like let me just take a look at my JavaScript code so I can tell you exactly. You could think of it like the max method, or like the reduce method for arrays inside of JavaScript, where you have an aggregate and then you have the current number and then you update. But the reduce method combined all of the results. This is going to only get what is the maximum of them, okay, in that scenario. So inside of here, we are going to pass in first, we need to have, remember, a basis for comparison. And in the previous languages, the basis for comparison was the first item of that array. So in our first array, the first item is going to be 10. And yeah, I could select, I'm just going to select the input type because there is just still a lot remaining in order for us to get to this point. So if this is the input type, the first item is going to be 10, and that's going to be the basis for my comparison. And how do I select that? Well, it has an index of 0. And then this is going to be the syntax for a closure function. For this closure function, I'm going to have two parameters. One is going to be A and the other one is going to be B. So we have this A and we have this B. Now, you might be asking, what is this thing right next to this ampersand right next to this B? This means B is actually a reference to a number because in each iteration it references one number. But this A is actually one number. That's any number. That's any number that's going to be the largest number. So that's why A is actually a number. That's why there is no ampersand after it. But this B is going to be a reference to a number. And now let's go ahead and let's complete this closure function. For this one, we are going to say if, let me just try to implement the logic. We're going to say if B is greater than A, then we're going to keep the value that B has. Otherwise, we're going to keep the value that A already contains. And the value that it contains, that's going to be the basis for our comparison. There we go. So now we have the maximum or the largest number within our array stored within this max. But then we need to return that from the function as well. And when I say return, that means I'm talking about the output of the function. So for that, I need to use the result enum. And since this is a number, I need to select the number property and pass in the max in there. There we go. So far, this is okay. This is completed. The only thing remaining for us is actually invoke our trait implementation so they convert the values for us. Here you can see we actually defined this function, but we never invoked it. We did a function like this here, we had one here, and then we had one here. But we never invoked any of these functions. So if I have not invoked them, how are they going to convert these? How are they going to do this conversion for me? So in order to invoke them, we are going to use a custom macro, much like this one. That's where these two solutions are going to have some overlaps, but this is going to be different. So this custom macro, it has some things that are part of its syntax, like this macro rules. The name of this macro is going to be find_max. And then let's define this. So this macro is going to handle two different cases for me. One case is going to be if user passes an empty vector or an empty array. Let's first handle that since that's easier. If user passes something that's empty, our pattern or our pattern basically is going to be empty. So let's handle that. We're going to call our find max and we're going to pass in something that's empty. What is that's empty? There we go. That's a vector, right? But keep in mind, the function accepts a slice of that. There we go. We pass in an ampersand just to denote this is a vector slice. So this is the very first edge case if user passes an empty vector. The second edge case is if user passes something within that input array, right? So that thing could be a mixture of numbers and string. that array could be only numbers, that array could be only strings. So we need to handle all of them. Now, inside of the pattern, what do we pass in? Well, we need to specify generally what this macro is going to calculate and how it is going to invoke the find max function, right? We need to do this generally. So here, the first thing is the square brackets. Let me just zoom this in, and you're going to see this is very interesting. So this is the syntax for a vector because that's what we want to denote that the function accepts. But within the vector, we might have several items. So there should be some sort of a repetition pattern, right? We've already talked about this. And the vector has expressions, EXPR. But we need to denote these expressions and name them. Why? Because these expressions, they could be numbers, they could be strings. We need to store them temporarily so we can convert them to their specific or appropriate types. And for conversion, you need to have access to that variable's value. So in the v1, I called it x, and here I could call it element, right? And then I need to denote this, that this is a meta variable using a $sign as well. So this is going to be a repetition pattern, but then with how many times do we want this to be repeated? We want to say 0 or more times. So in this scenario, we're going to have an input array. I'm just going to call it array, and we want to convert it to a vector using this macro vec. But this conversion is going to happen for every individual item within this vector. So let's select our repetition pattern, and we are going to say, I'm going to select. Now, why am I selecting element and not the result? Because in this one, I'm talking about what the function accepts, the input. The input is my element. The output is the max result, right? So in here, do I want to specify which of the implementations I want to use? No. Why? Because I have 4 different implementations. I have 4 different traits. Do I have to can I create one basically conversion to handle all 4 of them, or should I create 4 different macros? I could do it in one. And the way I'm going to do it is just keep it as generic as possible. So we just pass in that element in here. And this element could be an integer. And then if it is an integer, it goes to the trait implementation that handles integers. If this is a string, it's going to see owned or slice. If it is slice, it's going to invoke that specific trait implementation. So what do I mean by this? Let's say this element is number 10. So let's move forward. Which of these implementations handles that integer? This one. So we invoke this function right here. And what does it do? It accepts an integer, very good. And then it calculates that integer by converting it to a floating point number. So this is how these trait implementations work. What if we hit a string? Well, is it a slice of string or is it an owned string? Either way, we're going to go to one specific trait implementation. What if user passes 8.9? This is a floating point number. So we invoke the trait that is responsible for that. Since it's a float, we don't convert it. We just funnel it through our element back to the function, to this find max function. Right? So this is like a more generalized way of writing or invoking our trait implementations, like a general way of doing it. And then we want this to be repeated 0 more times using this star right here, right? Now, we have our input array. What do we do with this input array? Well, we need to pass it to our function. So we invoke our function right here and we pass in the input array, but this is going to be a slice of it. So we need to pass in that ampersand. All right, and that's it. That's our macro. All right, so what do I want to do next? Well, you could hit the brakes. You could just print everything to the console and you're going to see your result. But what I'm going to do next is going to be to define and to basically structure the output that we actually get. I want that to be structured a little bit. So for that, I'm going to specify another function. And this is going, the job of this function is solely to format the output of this entire challenge. So that's why this function is called print result. Now, what is this function going to accept? It's going to accept a label that is going to have this type, and it is going to accept our result. Now, since I'm talking about my result, what is going to be the type of the result? It's going to be max result, right? Now, I am going to create a variable, and the job of this variable is to basically define the type of the input. Sorry, the type of the output that I want to produce. So I'm going to call this let type underscore name, type underscore name, and we're going to use pattern matching to determine which variant or which member of this max result we want to use. So in here, I'm going to say match. Let's grab our result here and let's open up our curly braces. So in here, what do I want to do? Well, I have only two variants inside of my max result. I just have two members. Let's select both of them. One is of type number. The other one is of type string. Now, since I'm only interested in the types, am I interested in what the actual value is? No, I'm not. Since I'm not interested, I'm just going to pass an empty, an underscore, specifying that I'm not interested in the actual number 10. I'm interested in the type of that number. And I want to store that within my type name. So if I hit a number, that number could be anything. It could be 1 to whatever. As long as the type of it is a number, I want to produce a message that's going to say number. I want to produce something, a string that's going to say number. All right. What if we pass in it? We have a string, right? Then if, oh, well, this should not be string. This is going to be message. And the type of this is going to be message. Now, when it comes to our max result, we just have two variants. We have number and then we have message. Message is when user passes only strings inside of the input array, and number is when we find the largest number within that array. So now that I've handled this, let's use the print macro to actually style our output. Now, the job of this print macro is to, again, style our output. So how do we do that? Well, we need to have our display specifier. But before putting the display specifier, you need to know what that is a placeholder for. So we have our label, and then after the label, we have the type name. So the first specifier is going to be for the label, and the second one is going to be for our type name. There we go. Let me terminate this as well. And we use print over the print line macro because this macro, this prints the text without a new line. But print line, it always adds a new line at the end. And the final thing that we need to do is to actually decide how to print the final output. So that decision is going to be a little bit tricky. Why? Because we need to see if we have integers or if we have floats. We know the function can accept integers, the function, because we have already created the enum element and we talked about trait implementations. So we talked about all of them. But at this point right here, since we only talk about what the function produces, there is no need for me to talk about the element. The only thing that we concern ourselves with is this max result. So in this scenario, if I want the result to be shown on the inside of the console, how do I want it to be shown? So do I want to have do I want to have decimal points after integers as well? So if I have 23 as the largest number, should it be 23 or 23.0? Well, that's a preference. I want it to be 23. But if I have, let's say, 150 or if I have 150, I want it to be shown as 150. I don't want it to have like 0.0. Or in this scenario where we have 12, the same thing. But what about this one? Now, this is 4.7. We know this is the largest right here. But do I want it to be shown as 4.7 or as 4? Of course, I want it to have that decimal points. So if I have an integer, which is the largest number, I don't want it to have like a trailing 0.0. But if it already has a decimal point, then I don't want to get rid of that. So I want to keep the number as it is. So for that, we need to actually match the result. So how do we match the result? We have two different results. We have a result that has a type of number. We could call it n. And then we have a result that has a type of string. And we could, this is not string message, and we could call it MSG. Let's first handle the message one. This is easier. So if there is a message that we want to produce at the end of our result, how do I want it to be shown? Well, I don't care. It's just a message. I just want to show a string, and that's it. So here I'm going to use our print line method or macro. And for this one, we just want to show the message. But since we're in Rust, we need to have that display specifier or that placeholder for that message. So this part is done. The tricky part is this number, because if it is an integer, I don't want to add a 0.0 to it. But if it is a float, I don't want to get rid of that decimal point. So it is a little bit tricky for us. Now, hopefully or gladly, we are in Rust, and there is a method that's called fract. And fract is basically going to return the fractional part of any number that has a type of f64. So we're going to say if this returns 0.0, that means we have hit an integer. It doesn't have any decimal points, and we don't want to add a decimal point. Where is our f? Here is our f. And on which basically value or variable do we want to call this fract? On n. So if n doesn't have any decimal points, aka n is 0.0, n is like 10.0 or 23.0, then we want to convert it to an integer. It means this is an integer. I don't want to add 0.0 at the end of it. So how do we do this conversion? We can do it in line. So here I can just pass in my placeholder for that number, and I can say n. Now, keep in mind, what is the type of n at this point? The type of n is f64. Why? Because that's what we specified here. See, our max result type of this is f64. Okay, so if the type is f64 and I want to produce an integer, how can I do this? I can cast the type. I can say n as i32. That's it. N as i32. Let me add a comma here as well. But what if this is not the case? What if the number has decimal points like 4.7? Well, in that scenario, we don't want to do anything. We just want to return that number. So print line, and in here, display specifier. We don't want to do anything. We just want to return that number. So we keep this balanced, right? If there is, if it is an integer like 23, we check it using the fract, and fract tells us, okay, it doesn't have any decimal points. Then we convert it since it doesn't have decimal points, but f64 says 23 is not 23. 23 is 23.0. And when we say as i32, we get rid of that 0.0. And we say 23 is 23. Else is going to be if we hit 4.7. So 4.7 is 4.7. This variant number from our max result, it already expects 4.7. So I don't have to do any conversion. And I don't want to change the value of 7 to 0, 4.7, right? To 4.0, and then, or to just basically 4, I'm just going to pass it as it is. So this is going to be our result. And what is the final thing that we need to do? Well, we need to call all of our test cases, and I'm just going to copy paste them here. So here are all of our test cases. But among these, you need to pay attention to a very important thing. And that is, we're not calling our function find max. We're calling the find max macro because everything moves through the macro. So if I were to give you an overview of how this entire thing moves, we call our find max macro, we pass in a specific array. If the array is empty, I'm going to try to go a little bit fast, even though I can't. So let's just start from the beginning. How does the data flow? Everything goes to our macro first because find max is going to be the function that the user invokes, and the user adds any kind of input array. And this macro is going to check first. If this is empty, if the input array is empty, it's going to call this find max function with an empty array. And what is this find max function going to do? It's going to return 0.0, right? 0.0, and then we invoke our print result function. All right, we take a look at the type of this 0.0. Well, the type of this is number, so we need to print this number, right? And then we are going to match the result. And how do we match it? We say, okay, 0.0, that's an integer, right? It doesn't have any decimal points. So we convert it to I32. Therefore, we are going to return just 0. We're not going to return 0.0. Okay, that's the first scenario. The second scenario, if user passes anything inside of the array, if it has numbers, if it has strings, or if it has a mixture of both of them, then we invoke this case. And in this case, we iterate over all of the elements. We do the necessary conversions when we iterate over the elements. Remember that. Based on which trait implementation is going to be invoked. So if the if user, let's talk about a mixed one. Let's talk about this one. So user has passed, the first item is 10. So it is an integer. Therefore, we invoke this trait implementation. We convert that integer to float 64, and then we go to the next one. Now keep in mind, we need to convert all of the array to their subsequent, basically to their corresponding types. Then we invoke the function with it. So we converted 10 to F64. Hello is going to be converted to an owned string. 23 is going to be converted to F64. 150 is going to be converted to, this is going to be an owned string for us as well, because at this point inside of our macro, we have not specified the conversion or the parsing of strings into numbers. So this F150 is going to be still a string, but an owned one. This 5 is going to be an F64 as well. So after all of this conversion, we store the result inside of this array, and we invoke our find max function with it. So find max function accepts that array. The array is not empty, so it's going to skip this if statement. It's going to create a numbers vector, and it is going to iterate over that input array. In the first iteration, it finds a number, it pushes that to the numbers array. In the second iteration, it finds a string, so it invokes this member. In this scenario, string is not going to be parsed to an F64 because it says hello. Hello cannot be parsed to it, right? So it doesn't put it inside of the numbers. The numbers array, it just has one item, and that's number 10. And then in the next iteration, it's going to select which number is next? 23. 23 is a number, so we push it using this line into a numbers array, and numbers array has 2 items by now. In the third iteration, basically in the next one, we have this 150. So 150 is a string, so we go to this item or to this match, and we say if we can parse it. And we can parse 150. So after we parsed it, we put it inside of the numbers. And keep in mind, numbers array so far has 3 items. 10, 5, no, 10, what was the, why do I keep forgetting? 10, 23, 150. 3 numbers so far. And in the final iteration, we take a look at 5, which is also a number. we push it to a numbers array. So a numbers array contains 4 items, 10, 23, 150, and 5. And it does contain something, right? So we skip over this if statement because it's not empty. We go here and we check which of these is the bigger one. And we can see, and we know that 150 is the bigger one. And then we pass that 150 to our max result. The max result is going to be invoked right here. And 150, is it a number? Yes, so we print number. Let's move forward. So 150, if we want to match the result, is it an integer? Yes, so it doesn't have any decimal points. So we need to, but even though it's 150, you can see the type of that is if64. So we need to cast it as I32. And then we basically call it. That's it. We print that right here. And the same thing goes for all the other ones. And now let's see how many errors we are going to get. Rust C, E tab. This is going to be v2.rs. Let's run this. Okay, it says add this here, unexpected token. Oh, whoops. I need to add a semicolon there. There we go. That's our semicolon. And what else is the problem? Expected line 71. Line 71. Oh, there should be one colon there as well. So we forgot our colons. Let's run this. And oops, which one did I run? Okay. Yeah, it just keeps on going. Let me clear this and let's run this. Okay, we have a ton of issues. Let's go to the top. It says find max line 80. Where is line 80? Didn't I add that? I did add it. Okay. And then line 91. Line 91. Let me zoom this out a little bit. So it says on line 91. Found this expected pair, expected one of these. Line 91. We don't need this. Oh, I added that in the wrong place. And then element expression, no rules expected. Let me take a look at our macro. This should be inside of that because we don't want to repeat the array or the vector. We want to repeat the items within the vector. So that's why it should be repeating 0 or more times any item of the vector, right? Not the vector itself. And calling this macro, no rules expected this. Oh, let me just clear this and run it again. And there we go, it compiled. It was, the problem was with that, a couple of colons and that star. So, and finally, let's run this. So we have, instead of v1, we want to run v2. There we go. So the thing that I added here, let me just bring this down, this number and this message, you can see them right here. So since 23 is a number, we can see number, and 0 is also a number. And you can see there are no decimal points after 23 or after 0, after 150, after 12. But since here we have decimal points, we just keep them. So this is a number, floating point number. And then if user passes something like apple and banana, we have this, you need to pass numbers, and the type of this is message. Very cool, right? And so with this, our entire challenge has come to an end. I really enjoyed creating this challenge, and I enjoyed even more teaching it. See you in the next one.